Welcome to the Explainer. You know, when you look up at the night sky, do you ever wonder if it's all just random chaos? Well, today we're breaking down an argument that says no way. It views the cosmos not as some big accident, but as a system of perfect law and order.
So to get this, we have to start with the chaos, right? The source material paints this picture of a universe that is just unbelievably violent. We're talking about nuclear explosions out there that pump out more energy in a flash than our sun will in its entire lifespan. Just try to wrap your head around that.
And from those explosions, you get these insane shockwaves just tearing through space at 30,000 kilometers per second. I mean, can you even picture that? It's a scale of speed and power that just seems completely out of control.
And it's not just explosions. You've got black holes that could literally devour our entire galaxy. And what, for the universe, is the blink of an eye. This whole picture sets up a universe that really seems poised to just tear itself apart.
Okay, so in a universe with all that devastating power, how are we even here? How is our existence even possible? That's the big question the rest of this argument's going to try to answer. Okay, so let's dive into the framework that tries to explain this. The source points to the work of cosmologist Sir Martin Rees and his book on the 6 numbers. And the idea here is wild. Our entire existence seems to hinge on this handful of finely tuned cosmic constants.
So let's take a look at 3 of these crucial numbers that, according to this argument, govern the entire universe.
First up, we have a number called n. Now, n represents this fundamental balance of cosmic forces. It's the ratio between gravity, the force that pulls all matter together, and the electrical force, which is what pushes it apart at the atomic level.
Now, get ready for this, because the scale of this number is just, well, it's a 1 followed by 36 zeros. It's almost impossible to comprehend. And what it tells us is just how mind-bogglingly weak gravity is compared to the other forces.
And this right here, this is the core point of the argument. If that number, n, were even a little bit smaller, the universe would have been short-lived and miniature. Basically, there'd be no time for any kind of biological evolution. But because it's exactly what it is, we get a stable universe that can sustain galaxies, stars, and complex life.
Okay, let's move on to the next constant, epsilon. This one is all about the stars. It basically dictates the efficiency of nuclear fusion, or, how much mass gets converted into energy inside every star, including our sun.
And the value for epsilon is precisely 0.007. According to the source, this exact value is the reason our sun doesn't just burn out way too quickly. It gives us that long, steady burn needed for life to emerge.
And here we see another razor's edge. If epsilon was just a bit lower, at 0.006, hydrogen just couldn't fuse. No stars, no planets, no life. But if it was a bit higher, say 0.008, all the hydrogen would have been fused up by now. No water and, well, no life. A tiny deviation in either direction, and we're just not here.
All right, finally, there's omega. This one is all about the density of the universe itself. Think of it as measuring the total amount of stuff in the universe, and it's what balances the force of gravity against the expansion energy from the Big Bang.
So the point here is crucial. If omega were too high, the universe would have collapsed on itself a long, long time ago. But if it were too low, gravity would have been too weak to pull anything together, meaning no galaxies or stars would have ever formed. The expansion speed seems to have been perfectly tuned from the very start.
Okay, so now let's bring the scale way down, from the cosmic right to our own planet. The source presents even more examples of this really delicate balance right here.
23.5 degrees. You probably remember that from school, right? That's the Earth's axial tilt. And the argument here is that this tilt is absolutely critical for giving us a moderate climate. And look at this. The argument lays out these different climate scenarios, and the margins are razor thin. If the tilt were just 22 degrees, Arctic ice would just cover the northern hemisphere. If it were 25 degrees, the polar ice caps would melt and flood the planet. But at 23.5, we get a moderate climate and predictable seasons. It's wild.
And this same logic is extended to how fast the Earth spins. Our 24-hour day is presented as another one of these non-negotiables for life. If it were, say, 20 hours, organisms just couldn't complete their life activities. But if it were 30 hours, we'd have constant hurricane-force winds scouring the entire surface of the planet. No thanks.
The source even points to the chemical properties of oxygen as evidence of this kind of designed balance. Think about it.
Oxygen is actually pretty dangerous stuff. It's deadly, corrosive, highly flammable, even toxic to breathe in its pure form. And yet, it's absolutely essential for water, and it's essential for all life. It's this perfect paradox.
So, what's the ultimate conclusion drawn from all this evidence? What are we supposed to take away from all of this?
To help frame this, the source brings in a quote from Marcus Aurelius. "Dwell on the beauty of life. Watch the stars, and see yourself running with them." It's a way to kind of shift the perspective from just dry scientific constants to a real sense of cosmic harmony.
And that brings us to the core assertion here, that these phenomena are not just a bunch of lucky coincidences. The conclusion is that lucky accidents are basically an unknown concept in the universe. Everything is ordered, structured, and in perfect balance. And this brings us to the final, provocative thought. What you should take away from all this is the question of how you interpret this apparent fine-tuning. Is this ordered universe just an accidental coincidence? Or is it something more, an intentional creation?